And the wind picked up, the fire spread, and the grapevine scene left for dead. The northern sky looked like the end of days, the end of days.
Okay, welcome to Chem 127, lesson number 4. Starting things out with some combustion-related music today, which will be appropriate. Today, we're going to talk, the goal here is going to be to talk about chemical mass balance. This is what we're going to get through today. The first thing, we're going to learn a problem-solving technique that your high school teachers probably beat into your head called dimensional analysis, sometimes called the factor label method by some high school teachers. We're going to see that that's going to be our platform to getting into chemical mass balance. We've got to inquire or learn about these things called moles. Everyone's going, eek, I'm going to run away. I didn't understand moles. You will understand moles after that. It's not really that big of a deal. And then the end goal here is just to be able to calculate how much stuff we produce when we react a certain amount of substance. In other words, if I burn a kilogram of propane, how much carbon dioxide do I produce? How much water do I produce? How much oxygen do I consume? Those are the things that we're going to do. There's a smidgen of this in the middle of chapter 3. I'm going into it in a little bit more detail, but you might find that helpful. There's a couple of problems related to that there. Most of this is going to be in my homework number 2. So again, this is not a bad idea to sort of print that out and follow along. You can even pause the video after the sample problems and just do those problems and check your answers. You have the flexibility to do this how you want to do it. I would say that's one of the advantages of this format. So there you go. Go over here. Okay. Dimensional analysis. Okay. Again, this is a powerful quantitative reasoning tool in the sense that maybe you've been taking a science class before and you've had trouble doing a problem. Saying, geez, I got the numbers here. I want to do this calculation, but I can't find the formula. Dimensional analysis helps you put those quantities together whether you have the formula or not. And the idea being that, each number has a certain set of units associated with it. You're not driving 55 on the highway, you're driving 55 miles per hour. And if you were driving some number of kilometers per hour, it would be a different number. The point being that the units or the dimensions on the number make a difference. And those numbers, those units can also tell you how you need to multiply or divide the numbers to get the desired quantity. And I'm just going to kind of start with a mundane illustration here. Maybe you're comfortable with this already. You could watch along. You can always skip forward, whatever you want to do here. But I'm going to do a mundane illustration here that's basically just a unit conversion. And this is why people groan when they see this, is that your high school science teacher just made you convert from one set of units to another set of units. I'll do an example here in the Pencast that shows you that this is actually more useful than that. The idea here with a unit conversion here is that, I can multiply a number by a fraction equal to 1 and the value doesn't change. And that's the rationale by being able to multiply, say, a speed in miles per hour times how many kilometers there is in a mile to get kilometers per hour. And it's a different number, but the quantity is the same. We have a different number and a different set of units, but the speed in miles per hour and kilometers per hour means the car is still going the same speed. Okay, so I'm just going to sort of do a mundane example here in PowerPoint first. And this mundane example is just the question, how many inches are there in a kilometer? Now, one of the things you're going to start seeing here is prefixes like kilo, etc. And I'm just going to show you a link to these things. You can just type this into Google. Here you go. Here are the metric prefixes. Here are the ones that you're going to need to be familiar with. Kilo is 1,000 or 10 to the third. Centi is 10 to the minus 2. That means there's 100 centimeters in a meter. Milli, 10 to the minus 3, 1,000 millimeters in a meter. We will also deal with micro and nano. Micro is a millionth, or 10 to the minus 6, and nano is 10 to the minus 9th. And we'll just kind of let that go at that. But you need to go back and refamiliarize with yourself with those things, and we'll just say goodbye to that little Google window there. Okay, getting back here. So when I do a problem like this, And whether it's a mundane unit conversion or a real problem where I'm trying to find the answer to a real question, what I'll do is take what I'm given with and just write it on the left-hand side of the piece of paper, and then see where I'm going over here on the right. And then once you develop the strategy or the techniques for this, you're going to find these factors equal to 1, and you're going to strategically place them here. And it's hard to see where you're going until I actually get them down. But I'm just going to show you what I do, and I'll go back and explain it when I'm done. Okay, so the first thing I'm going to do is I'm going to multiply that by 1,000 meters per kilometer. I'm going to multiply that by 100 centimeters per meter. And the reason that I did that is ultimately to get between metric distances and English distances. The thing I remember from middle school is that there's 2.45 inches to a centimeter. So I'm going to write that by 1 inch times 2.54 centimeters. Now, again, the rationale here is that each one of these things is equal to 1. That is to say that 1 kilometer is equal to 1,000 meters. So if I turn that into a fraction and say, all right, I'm going to multiply it by 1,000 meters over 1 kilometer, I'm just multiplying the quantity by 1, and I can do that. Similarly, if 1 centimeter is 100 centimeters is a meter, I can multiply that by 100 centimeters divided by a meter. That's a fraction equal to 1. And lo and behold, if 1 inch is 2.54 centimeters, I can multiply that by 1 inch divided by 2.54 centimeters. And then I can multiply this together and get a quantity in inches. Well, how do I know I'm getting a quantity in inches? Well, let's take a look here. The idea is that these dimensions, the units on the numbers, cancel just like numbers in a fraction. In other words, if I were to multiply 4 times 1/4, the 4's would cancel. And the same deal goes here, and that if I have a number in kilometers, if I multiply it by something divided by kilometers, the kilometers cancel off. And then at this point, I would have 1,000 meters, which would be the same distance in a new set of units. But I don't want a distance in meters. I want a distance in inches. So the next thing I'm going to do is multiply this by something over meters. And then the meters on the top there cancels with the meters there. And now at this point, if I stopped, I would have a number in centimeters. It would be 100,000 centimeters per kilometer. And I'm going to take this one more step. I need a fraction now that cancels off the metric units finally. Centimeters up here, centimeters down here. Those cancel out. Again, just like numbers, multiplying fractions together. And then ultimately, the only dimension I have left is inches. And if I were to take 1 times 1,000 times 100 and then divide it by 2.54, I would get this 3.9 times 10 to the 4th inches. And the alignment's a little off there, but I think we get the idea here. Okay, I had to go back and make a little edit there, so I realigned this. I'm sure that that really helps everybody out as much as it helps me. What I'm going to do here now is direct you to the Pencast. I'm going to work through a more interesting example which shows you how to do this to answer an actual question. Okay, so we're going to go back to Pencast 1B2 number 1, and we're going to pause that here for a little bit, and then we'll come back and do the sample problems. So I'm just going to sit here and pause that like that. Okay, welcome back from the Pencast. Now what I'm going to do here is just go forward here through some sample problems that are pretty straightforward. And again, the idea is that, you know, if you were sitting in class, you would sort of work through these on the fly. And I think they're pretty straightforward. One of the things I just want to plug this here too is that I put a link to this Bill Gates talk on, of all things, climate change. It's a TED talk. I don't know if you're familiar with these, but they're these little 20-minute talks by movers and shakers. And it's interesting as he puts forth this equation by how to think about dealing with climate change. And the basis for that whole equation it's rooted in this dimensional analysis thing that we're talking about. Here's a link here. It isn't going to work for you, but there's a link on the D2L site that I posted there. If you fast forward to about 4 minutes, you'll see that he puts this equation up there. Watching the whole thing is probably 20 minutes well spent. Okay, so here's some sample problems, just so that you can work through some of these on your own and see how we're doing it. Okay, so the first one here is okay. That is bugging me. I'm gonna fix that on the fly. This is just like it's in class. Okay, now those are fixed, and we can deal with it a little better. All right, some sample problems. Okay, a couple easy ones. 65 miles an hour. How many hours does it take to drive 500 miles? Okay, and do these, maybe these first two together. The next one is at 15 miles per gallon. How many gallons of gas does it take you to drive 1,500 miles? Okay, so what I'm going to do here is pause that a little bit. Okay, hopefully you've had a chance to do these first two problems. For the first one, you should have gotten 7.7 hours. And, you know, that's going to be 65 miles per hour. What you're going to do is take this 500 miles and multiply it by 1 hour per 65 miles, and you'll get hours. So you want the you're actually going to take this and flip it over and multiply it by the 500. 15 miles per gallon. Okay, we want to drive again 500 miles, and we need to flip that over again and multiply it by gallons per mile, and you should get 33.3 gallons. Okay, and you know that should make sense. What I'm going to do is do the solution to this one a little bit further out there, and so I'm going to pause and give you a chance to do this. If you had any issues with these, just let me know. Send me an email. I think they're pretty straightforward. I could be wrong about that. So now I'm going to pause here one more time, give you a few minutes to work on this, or as long as you want, and then I'll come back and I'll actually post a solution to that one. Okay. Again, these are pretty straightforward problems. This one's a little more challenging, so let's go through this. We're going to do how much air in liters do you exhale in 1 year? If you take 15 breaths a minute at 3/4 of a liter per breath. Okay, so pause, take a chance to work, some time to work on that one, and then I'll post the answer to it. Okay, should be 5.9 is about 6 million liters of air in a year, which is kind of an impressive number. Here's how that calculation works. Okay, we've got breaths per minute. We actually have liters per breath, so I'm kind of treating breath as a unit here. So if we take breaths per minute and multiply that by liters per breath, what we get there at that point, as the breaths would cancel out, we would have liters per minute. And then I just need to convert the minutes to years. So we multiply that by minutes per hour, cancels the minutes. Hours per day, cancels the hours. Days per year, cancels the day. In the end, what we end up having here is breaths per year, or excuse me, liters per year. So that number could be liters per year. The question kind of includes the units in liters per year. If you were to answer a question like that in liters per year, it would be perfectly acceptable. So that gives us the end of the first part of this lesson, and I will see you back in a few minutes for the middle part of the lesson.